Good afternoon, everybody. Welcome back to lecture number, I believe it's 9. So 3 weeks have gone out of 15 weeks. That's what, 20%. So 20% of the course is done, and I think we are slow, but that's fine. So last time we talked about the example that they are solving it using what? They're solving it using phasor diagrams. And I'm going to tell you why phasor diagrams are somehow better when it comes to these kinds of problems. This is not 360. This is a little bit more advanced. So if we look at example 3 where you have the infinite bus, I'm going to draw that portion's single phase diagram with equivalent impedances. So what I'm going to have is I'm going to have J3, J.3, you know why? 0.6 parallel with 0.6 per unit. So it's not an ohm, it's in per unit of ohm. Depending on ZB, we don't know what's ZB. And then here what do we have? We have V of t equal to a magnitude and an angle. We're taking it as a reference. Because last time I told you if you take the infinite bus as a reference, you're going to have equations of two variables, etc. It's going to be complicated. So let's take this one at an angle of alpha. We call it alpha. And here we know the current. This is a generator, correct? It delivers. Machine delivers. إيش معنى machine is delivering? Generating. It's a generator, not a generating. Machine is a generator. Proper English, please. Okay? And there's one thing. Those who did the quiz, if I ask you written question, you have to write proper sentences. Okay? This is not difficult. It's not English 102, but when you go for a company and they ask you, what is the technical reason that we had a failure in this system? You can't say infinite bus. You cannot say short circuit. You have to write proper sentences. Okay? Proper sentences. So here what do we have? IA is what? Is 1 at an angle of 0. Why at an angle of 0? The key here is unity power factor. Unity PF implies V of t and I of A are what? In phase. So that's why this is 0, this is 0. If you take this as a reference, let's say VB as a reference, this will be alpha and alpha. Get it? So let's do the simple KVL. This is a voltage rise or voltage drop? This is a voltage drop, so we can say VB, voltage rise, if you want to do the KVL here, J.3 minus VT equals 0. What are you looking for? You're looking to calculate VT. So, VT is what? VB plus J.3 times IA is 1 per unit. Correct? And VB is what? VB is 1 at an angle of alpha. So this is VB, this is J.3 IA. Get it? So here is the trick. You have two unknowns, one equation. But what did we do? Math 0, 2. 0, 0, 2. Math 0, 0, 2. I don't know. They came up with theory, something like VT square equal to 1 square plus 0.3 square. Basically, you're taking the magnitudes of your complex number. You remember this? So, if you want to get...
بس طبعا مفروض مو كذا.
في خطأ.
مفروض 1 ساين الفا بلس يعني تجمع المجري مع بعض وتجمع ما
هي
فك هذه الجاوي فكها سير
لازم تفكها متأكد. واي هنا في السوليوشن ما فكر.
لا انتوا لازم هذه ال1
طيب هذه كيف هذا الحين كيف طلع؟
زاوية اوريدي زيرو.
زاوية زيرو بس انت هنا عندك زاوية ألف.
لا الفي تي زيرو هذا زيرو الفي بي هو ألف. يا اخي نظرية فيثاغورس.
اتكلم عن هذه فكري من هذه. اتكلم عن هذه.
نظرية فيثاغورس
هذه غلط. المفروض تفك الزاوية.
كيف غلط؟
حط 1.
طيب في تي عبارة عن ايش؟ في تي انجل زيرو equal 1 angle alpha
حلو.
plus j.3
مظبوط.
which we can say it as 0.3 angle 9 something like that. You agree with me?
ايوه يلا.
هذه كلها فيزر يعني هي vt e to the power j0 equal 1 e to the power j alpha plus 0.3 e to the power j9. You agree with me?
ايوه.
Magnitude of this equal to magnitude of that plus magnitude of this. يعني مثلا عندك z equal a plus jb صح؟ Isn't z square equal a square plus b square?
بي بس الحين هذه لو تفكها تصير كوساين ألفا بلس جي ساين ألفا.
طيب نفك
فكها زي كذا.
هذا نشوف ايش يصير. Equal to what?
كوساين ألفا
1 times cosine alpha plus j
ساين
sine alpha
بلس جي
0.3
ايوه.
j. Yeah, you're right.
ايوه زي كذا.
ايوه خلاص.
هذا.
What is this?
الحين
هذا ايش؟ VT.
هذه في تي.
VT. ريال مع ريال imaginary مع imaginary.
ايوه.
طيب يلا خلينا نسوي.
او
Okay, you're right. This will be done.
الماجنتيود بيكون سكوير روت 1. اكتب لك اياها.
You know, I'm not good at math.
تصير في تي سكوير روت 1
You're right.
ساين ألفا بلس 0.
لا مد تحت حد تحت.
ايوه شو ألفا سكوير زي كذا زي كذا.
Yeah, but
We still have to.
see
لا
the
انت
issue.
اخذت الماجنتيود. اوكي ماشي.
احنا الفكرة حقتنا. ايوه ممكن. طيب كوساين. طيب سوي لها سكوير.
ايش سكوير؟ سويتها سكوير.
ما نبغى نطلع 2 ساين الفا.
بتفكها يعني الفك دي.
This we are still stuck here.
We are still stuck يا أسامة.
لو بتفك هذا.
let's keep it simple. لو بتفك هذا تطلع ساين سكوير بلس 2 ساين الفا.
ايوه وهذه تكون معاها
هذا 2 ساين بلس ساين
طلع واحد.
1 بس في ساين 2 الفا وش حيصير عليها؟ اوكي خلاص. فليتس
انت بتجيب الالفا صح؟
let's do it as a vector calculation. It's easier. Vector calculation تقول لك VT plus IA equal to VB something like that. طلع عندنا هذه 1 minus square root of 1 minus 0.3. Let's think. You know how he got this? Not clear.
ترى الحين انا ما ادري وين تبي توصل.
اللي أبي أوصل إنه what is VB? Isn't VB? VB is an angle of alpha. You agree with me that VT and IA are in phase.
طيب.
Right? VB is another vector with a value of
الفا.
alpha. If you multiply, if you do VT times IA 0.3, you will reach up to VB. فيطلع عندك زي المثلث. فيصير VB square is equal to 0.3 square plus VT square.
طيب.
Because IA 0.3, if you add a negative sign, it would be VT minus IA 0.3 equal to VB. That's what I was trying to show here, is we will have VB, which is a complex number, equal to VT plus 0.3
جي.
J, IA is 1. These are two complex numbers.
اوكي كذا تمام.
بس هذه إشارة غلط ولا إيش؟ We have a KVL issue. Should be correct.
plus VB minus plus
With the naming.
VB
We
plus
are we mix the naming.
لا مضبوط.
بي تي تطلع هنا، هذه مو كانها ماينس.
لا،
فوق
مظبوط،
بي
مظبوط.
ماينس طيب.
مضبوط.
كيف اللي فوق؟
يبين هذا ايش يطلع؟ IA is going here. So VT plus IA equal to VT. VB plus IA equal to VT.
صح مضبوط.
طيب. So what is VB? VB is VT minus J.3. The J.3 already pointing up, so minus J.3 is pointing down. But that's why you know that VB squared equal to VT squared plus 0.3 squared. This implies that VT is square root of 1 minus 0.3 squared. فكرة إنه J.3 is pointing up. If you make it minus, it will be pointing downward. So you have to use the phasor diagram. Get it? Okay?
كذا تمام.
Now you get it? Now we all agree? The other one is much easier. The other one is draw another single circuit. واضح حسام? Please. The other one is what? J1. And here we have E. E or EF, it's the same. So VT, we already know what is its value? 0.54 at an angle 0. You agree with me? Same story. This is a generator, right? So E equals VT plus J1 times IA. Why it's J1? Because this is J1. So we draw a circuit here, then we draw another circuit there. Then we have what? 0.954 angle 0 plus J1. This implies E squared equal to 0.95 squared plus 1 squared. So E is what? A positive number, square root of this number. Get it? Which is 1.3.
بس امسحها هذه في الأسود VT اللي في الأسود تمسحها لأنه غلط.
هذه؟
إيه.
ليش غلط؟
هي غلط. اللي تحتها صح.
هذا VB.
اختلفت عن اللي تحتها اصلا.
إيه.
هذه قاعدة VT equal VB plus J.3. هذه غلط؟
هي صح بس بوينتلس يعني بتلخبط
Pointless, okay, خلاص نمسحها. خلاص, doesn't matter. So this implies that VB is what? VT minus J.3.
بالضبط.
If you take the magnitude, the magnitude of this square is magnitude of this square plus this magnitude of this square.
أيوه زي كذا أوكي.
بس ما له دخل الألفا والسيجما. This is a complex number. The magnitude of a complex number equal to the magnitude of a complex number plus the magnitude of the other complex number. نفس الشيء هنا. Now, E is 1.32. Let's proceed to the real power. So the real power is square. Do we multiply by 3? No. Why? Because we are in the per unit calculations. To get the real power, where are we measuring the real power? At the infinite bus. So we have to measure it using, we have to know, here's the thing. Why here he used VTIA cosine alpha, here he used VBIB sine alpha. If you measure it at the infinite bus, Q, you have to get B of the infinite bus and I of the infinite bus. So let's go back to the original equation. What's the original equation? S at the infinite bus is what? VB, IB, conjugate. You agree with me?
Yes.
Which is real power plus J times the Q. The problem we have here is he is saying that the real power that passes from this point to this point would sum up at the infinite bus. So if I measure the real power at Vt, it is mathematically equal to the real power leaving. But the complex power is not, because we're going to have we are having those two inductors that would make Q here not to equal to Q there. Get it? So to get the real power, he is saying that it is Vt times Ia times cosine theta. Cosine theta is the unity power factor between Vt and Ia. So the real power that goes from Vt to Vb is V of t, I of A, cosine of the angle of Vt minus the angle of Ia. But this cosine is 1 because it's a unity power factor from the problem. So you already have the magnitude of Vt, which is 0.9542 times 1. So the real power is 0.954. This is in watt or per unit? I think it's in per unit. This is per unit of power. To calculate the Q, I need to calculate the alpha. If I want to do real power at the infinite bus, I have to do something like VB, IB, cosine of theta VB minus theta IB, which is VB, I'm talking about this P, IB, cosine of, what is the angle of theta VB? Alpha minus 0. So I have to calculate cosine of alpha to get the real power. But here I'm taking a shortcut because I don't want to have two unknowns, P and alpha. So now we calculate the real power, which is 0.954. Now to calculate the Q, we have to calculate alpha. Why? Because this Q is what? VB, IB, sine of, same story here, alpha. So this term, I did not use it this way, I use it at the power like leaving Vt. But for the Q, I have to calculate alpha. And how to calculate alpha? We have to use basic trigonometry. And keep in mind why we did not multiply by 3. Because it's in per unit. Clear? ما في 3 في per unit. Let's do it this way. Now what do we have? We have here Vt. This is what? Minus 0.3 downward. And here I have V of B at an angle of alpha. What is alpha? المقابل على الوتر. مقابل sine of alpha. What is sine of alpha? المقابل, which is 0.3 as a magnitude, over الوتر. VB is 1. So what is alpha? Sine inverse of 0.3, and we have to include a negative number because it's downward. Alpha is a negative number. Depending when you say, you're gonna say
هذا الجنريتور ولا
the no, alpha ما له دخل بالجنريتور. ما له دخل. Alpha is the angle. ما له دخل. هذيك دلتا. دلتا الانجل between هذا وهذا. Alpha الانجل between الانفينيت bus والterminals of your synchronous. Not transmission line. Clear? No need to calculate alpha. I know sine of alpha is 0.3 over 1. مقابل على الوتر. This we can calculate Q to be VB, IB, sine of alpha, which is, what is the magnitude of VB? 1. What is the magnitude of IB? 1. What is the magnitude of sine alpha?
0.3.
No, it is 0.3. Because when you deal with, يعني أشرح لك إياها بالعربي إنه ألفا هذه هي a negative number، بس إذا أنت حاط السهم يبدأ من هنا لهنا it is minus 30. لو تحط السهم من هنا لهنا تصير plus 30. So when you put the vector diagrams, you put the numbers without their signs, assuming you know your direction. فإذا direction clockwise تصير a negative number. But it's a negative number. This number is 0.3, this number is minus 0.3. So Q here is what? 0.3 period. This is not easy, this is not 360. The problem here is you dealing with two different angles, two different references. One reference is for the transmission line, one reference is the terminal of the generator. So we finished part A. So we calculated terminal voltage of the generator, the excitation voltage of the generator, the real and imaginary power or reactive power at the infinite bus. And I told you that if you do the calculation to get Q for Vt, it will never equal to Q at B side.
Should we always take terminal as our reference, or depends?
It depends on your problem. I told you, you can make this as a reference 1 angle 0, but the problem IA, which is split here equally, will be at an angle of delta, which is in phase with Vt. So you can say terminal of the generator, maybe most of the time it's better because this is your reference.
Because your known is mostly in that side.
Mm-hmm. You can take even EF as a reference. If you take EF as a reference, this will be delta, this will be delta plus alpha. If you take this as a reference, this is 0, this is minus alpha, this is delta minus alpha. But now we're taking this as a reference, so this is alpha, this is delta. So this is as a phasor. This is V, B, e to the power j alpha. This is V, T, e to the power j0. This is E, e to the power j delta. And this is the torque angle. Get it? So if you shift anything, if you subtract alpha here, you subtract alpha here, you subtract alpha here. Then you're taking this as a reference. If you subtract delta, you subtract that delta, you subtract delta, then you're taking everything as a reference of. So always assign a reference. Get it? So at the infinite bus, he's telling you that the prime mover is adjusted such that the real power is 0. P is 0. Find the new excitation voltage if the field current is adjusted to get Q to be 0.5. It was 0.3. Now it is 0.5. How to solve this problem? If the real power is 0, what does this imply? It implies that theta of Vt, theta of Ia are 90 degrees because this has to be 90. And it is impossible to make Vt 0, Ia 0 if you have a reactive power running. Now if P and Q both are 0, then you can say I is 0. So to solve this problem, you have to go with the fact that the real power leaving Vt, which is equal to the real power of the infinite bus, P of infinite bus is same as P of B of T, has to be equal to 0. So this implies that cosine of theta of Vt minus theta of Ia is 0. So this implies that the angle theta is 90 degrees. So theta Vt minus theta Ia is 90 degrees. It means if this is 0, the current angle 90 degrees. Plus or minus, it doesn't matter for now. Now, if the power factor is 0, it means this Ia will be, according to this figure, it's 90 degrees. It's 90 degrees, minus. It is 90 degrees. So if Ia is 90 degrees, I'm making a new change. I know now for a fact that Q is VB IB sine of 90, which is equal to 1 times Ia. Why sine of 90? why V of B is in phase with Vt?
Because alpha is 0.
Hmm?
Alpha is 0.
Why alpha is 0? There is no information. And here sine 90 comes from the fact that Vb and Vt are in phase. We have to go back to the original equation. What was the original equation? The original equation of our diagrams is Vt equal to Vb. Was it what? Minus 3? Sama, what was the equation? This is Vb, Ia, 0.3. This is Vt. What was the original equation? Vt is what? Vb plus 0.3 Ia. You agree with me? But now, there is a j here. But now he is telling you that this is Vb, which is 1 at an angle of alpha plus j 0.3. Ia now is what? 1 angle minus 90. And this should equal to
VT.
Vt, so you should get a new Vt. Vt at an angle of 0, we're taking it as a reference. That's the change, And then you have to repeat the same story. Magnitude of this equal to magnitude of that plus magnitude of that. But to get the Q can help us get the new magnitude of Ia. Oh, I'm sorry. The current magnitude is different now. This is Ia. We don't know what's the new Ia. It's not 1. It's not unit. So, Vb and Vt are in phase. It means that, why it's in phase? Let's think.
Isn't it for the same reason we said that the angle at the cosine is 90?
لا هو الفكرة إنه قبل if here it is because Vb and this is Ia. The only way to get Vt is to be in phase. يعني this is from the phasor diagram and had a 90 degree. But the only way you multiply this, how can I say it? If you apply this equation, Vt is Vb plus j.3 Ia. You have Ia this way. j.3, it will make it in phase. Get it? Let me repeat. From a phasor diagram, V of t, you agree it's a reference, صح? Ia now, I'm telling you it's 90 degrees, صح? Vb is what? Vt phasor plus j Ia 0.3, صح? Vb, no, minus. صح ولا لا? You agree with me?
أيوه.
So I'm telling you Ia is at an angle 90 degree. Scale it with minus j.3. It means you're bringing it 90 degrees, so it will be in phase. So Vb is in phase. Now we know why Vb and Vt are in phase. Ia is at minus 90 degrees. If you multiply it by another 90 degrees and scale it with 0.3, you should get, this is what? A minus j.3. It's this vector. Vb is nothing but the addition of this vector plus that vector. That's why Vb and Vt are in phase. So this implies alpha is 0. Get it? Who did not get it?
نشوف إن شاء الله مقطع.
نشوف المقطع.
إن شاء الله.
الفكرة وما فيها إنه these slides are higher level. A higher level. He jumped the step. He told you this is 90 degrees, but how do you know it's 90 degrees? Because Vb and Vt are in phase. Cos theta is 90. Scale it down, which is this arrow, 0.3a.
I think there is a mistake. Cosine phi is equals 0 and unity of far factor. Shouldn't it be 1? Or is it 0? Correct. Cosine phi equals 0. Shouldn't it be 1?
Cosine 90 صفر. Cosine 0 is 1. So theta. It means
Oh,
I and V are in phase. But if you make
yeah. The second equation, yes, this expression.
this is a real power of this, the power factor is 0.
Oh,
Cosine of 0. No, you're right. This is a mistake. That's it. We correct.
okay, yes.
We'll fix it. Thank you. You're right. Fantastic. Clear? So here, the theta here is 90 degrees. Actually, this theta is same as this theta. Now we got the new Q to be 0.9, so we can calculate IA. What is IA? From this expression, VB is 1, IB is IA, the same. Sine of 90 degrees, sine of 90 is what? 1 equal to 0.5. So IA is what? 0.5 at an angle of minus 90. So from this phasor diagram, IA is what? 0.5 at an angle of minus 90 degrees. Now we can calculate our VT magnitude, which is VB. It was minus J plus J I A 0.3. So what is VB? 1 angle 0 plus J. What is IA? 0.5 at an angle of minus 90 times 0.3. We can add all of them together. You should get 1.15 at an angle of 0 per unit. So this is the new VT. The question asks calculate E. So again, to calculate E, we have to get the equation E equal to VT plus JIA, which is 1.15 plus J times 0.3 angle of minus 90. So the new excitation is 1.65 per unit. So please resolve this example at home. What will happen here is that if the real power is blocked from going to the infinite bus, we are only supplying Q at 0.5 power factor. It means E will increase now. E will increase from the original value of 1.38 to 1.65. Okay? I'm trying my best to clarify these slides. It's not easy. This is high level. The last part, repeat part A, if we lose one of the transmission line. What will happen if we lose one transmission line? This 0.3 will be 0.6. You agree with me? Yes. If this 0.3 is becoming 0.6, طبعا في جزئية في السؤال. Every key, the exciter is kept constant. إيش معنى exciter is kept constant? E is what? Magnitude 1.65. So if the exciter is kept constant, no, it's 1.382.
Because
Oh, this is repeat part A, not part B. معلش. This is part A, which is 1.32, صح? معلش 1.382. So if you're keeping the excitation at the levels of part A, and you lose one transmission line, are we in a stable region or not stable region? That is the question. So here in this question, how he solved it is the total reactance of the system is 1.6 per unit, because you have 0.6 here, you have 0.6 here plus 1. And the maximum power, if you do these calculations, the maximum real power transfer is E, which is 1.32 times VB, which is 1, the infinite bus, over the total reactance, 1.6. So the maximum power that you can transfer is 0.864. However, under these excitation conditions, the original power is 0.954. This is the original power, 0.954 in part A. Because 0.94 is larger than the maximum power, we go into the instability region. So the generator will lose synchronism if we disconnect one line. Any calculations you do is infeasible because the maximum power you can transfer is 0.864 if you lose one line. The maximum power that for 2 lines is what? 1.382 times 1 over 1.3. This is larger. Can anybody calculate this number? It's 1.382 divided by 1.3, which is 1.06. So 1.06 is larger than 0.954. So we are stable if we have 2 lines. But if we have only 1 line, we are in the unstable region. So we will lose synchronism. This example is a tough example, okay? Try to solve it, and if you cannot understand it, contact me. Clear? Is the YouTube still running? Enough about this example. Clearly, if you have line and a generator, things becomes complicated because what is our reference? Clearly, this is a little bit advanced. Now let's continue. Now, what did we notice? We noticed that if we connect the generator to the grid, we will have always problems. One major problem is, are we going to lose synchronism for that generator? But let's think about a bigger concept. Can a single generator ruin the grid? Can this generator in part C, it was out of synchronism, can it ruin the grid? No, because the infinite bus is by definition, it maintains 1 per unit and maintains what? 60 degrees frequency. It's not a 0 angle, it was at an alpha angle. Again, reference is, where is your reference? Our reference is Vt. If you take your reference as an infinite bus, yeah, it will maintain its angle. Now, what will happen is, this is a beautiful block diagram similar to the homework. Please do the homework. We have a generator connected to the grid. We measure the changes in real power. We measure the changes in the reactive power. And we have 2 feedback loops. The first feedback loop, from P and Q, I can estimate voltages and frequencies. The upper system is what we call the automatic voltage regulator, the AVR. It's in the homework. We get the voltage measurements, we put it into this AVR, it's control. It goes to the exciter and it increases the field current, and then we can increase E. For example, in part B, we had to increase E from 1.382 to what? To 1.65 in part B. How did we increase this? Well, we do the measurements in P, we do the measurements in Q, and we noticed that Vt would increase, so we increase the voltage. So we send the signal to the exciter to increase E. Why? To deliver the needed Q that went from 0.3 to 0.5. So that's why in this diagram, we always monitor the change of P, the change of Q, and the voltage. All of these all information, the voltage sensor would adjust the controller such that we increase the exciter or even decrease it. But that's not only the case, we also need to look at the frequency. So, the frequency, if I change the real power of a generator, if I increase the real power, what does increase real power of a generator mean? Put more fuel. If I put more fuel, it turns out that the grid may experience little bit drop around the generator. And it's measured in these curves. So we're going to have a delta F, minor delta F. If you push more fuel, there is a minor delta F. The whole grid frequency is 60, but the frequency at the terminals of the generator may not be 60 because I'm increasing the real power. There is another system that measures the frequency along with the changes of P and Q to what we call load frequency control, which has a reference of delta of real power based on this curve. Then I'm going to have valve control mechanism and adjust the steam of the turbine or the fuel to reflect, to tell the generator to slow down. Don't put more fuel. We have to maintain 60 Hertz frequency. So if you look at the homework, you may explore these two systems for your own knowledge. Okay? Try to explore them. And try, if you explore them, take some notes because you may need them for the project. Okay? So the reactive power is responsible for terminal voltage control based on excitation adjustments using the AVR. On the other hand, the generated frequency is controlled using speed governor system or load frequency control, LFC. And this is the system and how it looks like. So what do we notice here? We note that if you change the real power, or if you change the reactive power, you always have to control voltage and frequency. So time is up. We'll let you go. And please redo example 3, okay? Redo example 3. Do you have any questions? Okay, thank you.